So in the previous video, we found a good estimate of the area under this parabola. So if you haven't watched that, go ahead and watch that first and come back to this video. Now, in this video, I want to introduce the integral as an infinite sum of Riemann sums. So what we did earlier in the previous video was called Riemann sums, where we found an estimate of the area of the parabola using rectangles or using triangles. Now, let's actually introduce the idea of an integral. So let me erase all of this. I'm going to redraw our parabola. Let's redraw our parabola. We're going to draw it a little bit bigger this time. We have our y-axis and our x-axis. And again, we only care about the positive side of the parabola. And we know that the parabola looks something like that. And we'll stop at x equals 1. So let's say we want to figure out the area under this parabola from 0 to 1, which would be this area here that I have shaded. Now, so we in the earlier video we made 4 rectangles, and we said that the delta x for the rectangles will be 0.25, and the rectangles looked something like this. Well, yeah, let's make them a little bigger because we're trying to have 4 of them. So something like that. Oops. Where the height of the rectangle is determined by the function at that point, and the delta of the rectangle is determined by us. Now, what if we made more rectangles? What if we made 10 rectangles? So let's attempt to do that. It's a bit hard to draw 10 because we got to space it correctly, but I will do my best. So let's do 10. So we'll start here. That's our first one. Our next one will be here, like that. Our next one here. So far that's 3. Again, all the delta x's are equal, right? And the heights are easily determined by the value of the function at these x values, So let's keep going. So that's 1, 2, 3, 1, 2, 3, 4. And we might not get to 10, but it's 5. Probably do 8. 6, 7, and then actually here, let me redraw that one. That's 7, and then our last one is just at this point, and the height is just 1, and that's 8. Notice that us drawing more rectangles gives us a better estimate of this parabola. Now think about what happens if we keep drawing more and more rectangles. You know, if we make the rectangles 100 rectangles, you know, at this point we won't be able to draw it with hand, but we'll be able to draw that with a computer, right? We can sort of code a simulation that draws out essentially an infinite amount of rectangles. So pause the video and think about what happens as we draw more and more rectangles to estimate the area. Alright, so I'm assuming you paused the video and thought about it. So basically what happens if we draw an infinite amount of rectangles is we actually get the exact area under this parabola. And that's what an integral is. It's the limit as n goes to infinity, and n is the amount of rectangles, of the summation of delta x times f of xi. So let me break this down. So delta x is the width of the rectangle. So these are delta x, and they're all equal. And f of xi will be the height of the rectangle. And so this gives you the area of the rectangle. So what this limit says is that the limit as n goes to infinity, so the amount of rectangles being infinite, and finding the summation of all the areas of the rectangles. And this is equal to the famous integral from a to b, from some bound of f of x dx. And so we will discuss this, and we'll do some more practice in the next video.